Speaking of Michael Zolotov from Razor Labs, and welcome, Michael.
Pleasure to be here, Brett.
Thanks for chatting with us today. Well, let's start with Razor Labs, and give us your elevated pitch. Let us know what the company does.
Fantastic, thank you. So Razor Labs focuses on predictive maintenance and condition monitoring for mainly mining, processing, and smelting facilities. That's what we do. What is unique about us is that we use a very broad set of sensors that our system analyzes to provide really comprehensive coverage of equipment failures. And the way to think about it is, I think, very similar to how when you go to a doctor, and the doctor uses MRI and CT and blood work and ultrasound and so on. We do a similar thing by combining a very diverse set of sensors, sensors that are normally not so frequently used in operations, like cameras, oil sensors, vibration sensors, but also others like pressures and so on. And we combine everything to really make sure that we cover all failures. And not only that we cover all failures, but we can really point to the root cause of the failure so that when you handle it, you not only prevent this upcoming downtime, but also prevent all the further recurrences of that failure, and you really increase the reliability of the equipment on site. You prevent downtime, you prevent these catastrophic events that many times happens on site. You prevent many safety incidents. And we work today both in Australia, South Africa, South America, Europe. That's basically about us.
Yeah, great. So you're already in the mining industry across all those countries.
That's our primary industry.
Yeah. And how long have you been at it?
Wow, almost 10 years now.
Right. Okay, that's great.
Almost 10 years. Yes, it's been quite a journey.
And based out of.
So we have operations both in Sydney, in Perth, South Africa. Our R&D is actually in Tel Aviv, in Israel, but we really have people all around the globe to support customers, to expand, and so on.
And so the uniqueness is in the sensors, the type of sensors, or the analysis process that you're using?
So actually, the analysis itself, in essence, we're a software company. But what we provide to the customer includes both the hardware and the software. Basically, our pitch is that the moment we walk out of site, the customer has everything that they need in order for the system to work. So they don't need to care about what sensor do I need to install, which exact type, how do I install it or deploy it, and so on. So our offering includes both the hardware. So any sensor that exists, we use it, but many times, many sensors are missing. So we have local teams, Australian teams, South African teams, and so on to deploy these sensors. We have a gateway that basically collects all the data from the sensors and sends it to the cloud. And the bottom line is a SaaS product that anybody can just log into. They have full visibility of the site. They see all the machines. But most importantly, they see the bottom line diagnosis of what it found. It can be any material issues, belt issues, crusher issues, whatever it is, and what is recommended to be done. And this SaaS product allows them complete visibility of the data, of the diagnosis process, and obviously of the bottom lines. So that's what we offer.
What's the difference between the product that you're serving and, say, for example, a SCADA, just a monitoring system?
That's a fantastic question. Basically, SCADA is a fantastic system for operations. It was never actually meant or built for condition monitoring. And you can see it in several aspects. One aspect is the data that it can actually ingest. And I'll give one very simple example. If you look at failures, that are caused to pulleys, to belt wear, even crushers and mills. Many of these failures actually originate in the material itself, right? Let's say you have oversized ore caused because of crusher liner wear. We have tons of sites where these oversized ore would cause mill downtime. The mill is not to blame, right? You can replace the mill motor how many times you want, but it will keep on reoccurring. So one of the key aspects is actually looking at the ore itself, sizing the ore, looking at the imbalance of the belt, the alignment of the belt that cause deterioration of the pulleys and belt itself. And you just cannot plug cameras to SCADA. There isn't such a thing. So this entire aspect of monitoring the material, monitoring the belts, and so on, is just completely, is not there.
Right.
And there are plenty of other examples. It's basically like coming to a doctor and tying his hands and telling him, do not use MRI, do not use CT, only use, I don't know, blood work and disregard the rest. So
right.
it really limits not only what you can diagnose, but also how specific the diagnosis can be. Is it some 1,000 anomalies that the SCADA found yesterday, or is it something specific that you can really diagnose? That's a huge difference.
Great. So what does the process look like? What's the process look like for a company to install your product? If they say, yeah, it sounds good,
sure.
Go. Walk me through that.
Sure. So it's a very easy process. We really put a lot of R&D and a lot of effort over the years to really simplify it. Basically, it's 3 stages. Number 1 is we come to site for a couple of hours, 2-3 hours. And number 1 is we ask, what is the critical equipment for you? Are these the crushers? Are these the screens, the mills, some conveyors, ventilation fans? If it's underground, that's very important. So every site has its own critical equipment. And we first understand what is that equipment. Then we actually look at the equipment. We see what sensors exist. We do a quick tour, and then we do our own homework offline. We build what we call an implementation plan, saying these sensors exist, and these are the sensors that need to be deployed. Now we have our own methodology of understanding what sensors need to be deployed and where. Most of these are off-the-shelf sensors, right? We do not need to reinvent the wheel. But we know exactly these specific frequency ranges go to these machines, and these others go to those machines. So we build an implementation plan, and it's basically a short document that says to the customer what sensors will be installed and where. And that's basically it. We schedule installation with the site. It happens mostly a few weeks after. Our local teams come with everything prepared. They come with the sensors, they come with the gateways to site, we ship it to site. We do not require a shot to install the vast majority of the equipment. We literally just mount the gateways. Most of the sensors, the sensors that connect to machines that are not behind guards or cages can be connected during operation. And these small percent of machines that are behind guards, we connect them during what we call mini shots. These a few hours of shots that sites have every now and then. And that's it. From the moment it's connected, the system is up and running. They have full visibility over their tablet, smartphone. They get notifications if something is wrong or if something is deteriorating. And Brett, we have so many examples of literally millions of dollars that were saved, just because of, we identified this huge bearing deterioration that no other system has found. Or this specific, safety event that was, we had a site where a fan, for example, the bearing broke and literally the entire fan just exploded and, flew to like 200 meters from there. So imagine if it would land on somebody, it would just kill that person. So many of these events that can now be just completely prevented. It's not a SCADA style where you have, these thousands of alarms, but rather very specific. This is deterioration, a gear mesh here, material oversized there, looseness here, oil contamination there. So very specific, and you know exactly what to do. That's basically. Right.
Yeah. Okay. So, so are you mainly in like what you wash plants, conveyor systems, probably open cut or underground coal or metalliferous? Where are you sort of mainly operating in, and where's your target?
Sure. So if I go process-wise, I would say number one is, so first of all, we have underground mines. you have their conveyors, you have their ventilation systems and so on in large quantities. We do require connectivity, so obviously either LAN cable or cellular connectivity or whatever it is, as long as we can get the data.
Yeah.
Underground mines, all the processing plants, right? Gold, copper, silver, really everything. And as you said, after that we have refineries, smelters. So it depends on the commodity, and commodities can be like coal, but they can be also different metals like iron ore, gold, copper, even very more niche metals like vanadium and others. Really everything, and we have lots of experience with these commodities and these sites, so the system is already come prepared with all the knowledge, right? You don't need to tweak it, you don't need to teach it or to whatever. It already comes pre-equipped with all the knowledge.
So what sort of training? But you kind of answered it. It sounds like the system itself is already sort of pre-trained to give the alerts or the warnings that you require. What about the employee, the engineers looking at the information? I know with some systems you just get all the data and you've got to try and spend the next six weeks interpreting it all just to figure out what's going on. How do you handle that?
Really good question, because it also includes a kind of a psychological part, right? On the one hand, you cannot give the the user, the maintenance team, reliability team, you cannot just give them raw data, because then what did you do? It's like you go to a doctor, they present you the blood results and they don't right, they don't explain anything about it. On the other hand, you cannot only give bottom line and just say, believe us, that's what's going to happen, right? So you actually need all the layers. So first of all, exactly as you said, the system is already come pre-equipped with all the knowledge. It means that it knows about all the failure modes. It knows what can happen to a crusher, to a mill, to a conveyor, to a pump, a slurry pump or whatever it is. There is no training involved. We just have, this huge experience in databases of what can happen. There is some, I would say, configuration that we do, very basic ones. So for example, if you have a crusher and we need to look at the size of the ore, let's define what is good size, right? Is your crusher gap 180 mil, 200 mil, 250, whatever it is. So it's very basic, and we do it, not the customer.
Yep.
And after that, we deliver the customer what we call like 3 layers. Layer number 1 is bottom line diagnosis, right? Like the diagnosis that the doctor gives to a patient. That's what's wrong. That's what you need to do. That's the root cause. That's how you prevent it. Layer number 2 is what we call the evidence. So the system, and that took us many years to develop, actually is able to take the portion of the signal that tells you why it performed the diagnosis. And that's very important for reliability teams, common teams. So for example, if I'm looking at all the vibration coming from the machine and I'm performing this sophisticated AI processing, I'm looking at demodulation, I'm isolating some operation mode, I'm performing pretty sophisticated things, I would actually show you the signal, show you what I've got, and show you the deterioration that made me believe that this is the issue and why it is so severe. So they can look at it. They don't need to look at all the raw data and find it, but rather they are pointed specifically to the evidence. And now they can say, oh, okay, I got it. I understand why you performed this diagnosis. And the third layer is, as you said, like this generic exploration. You can look at all the raw data of all the history, all modalities, right? So we call modalities. You can look at the video footage. You can look at the spectral information. You can look at, operational data, pressures, flows, currents, and so on. You can correlate between them in the system. So you have complete freedom if you choose to. But if you don't want, you just want the bottom line, fantastic, it's there. So we give these 3 layers of
fantastic
granularity.
Yeah. So it reminds me of year 12 maths exams when you used to have to show you working. You couldn't just
you cannot give the bottom, the final answer. You need to show.
Yeah, that's it. That just means you cheated. So how about integration with existing systems? How do you handle, or are there specific systems that you already sort of integrate with, or is this something that is, you put it in, you basically, you add this tool to your toolbox and you would consult it on a, what frequency, or would you wait for an alarm? Give me a bit of an idea of operationally what it means once you've got this installed.
So it's a very good question. I'll start with the first one regarding integrations. So let's speak about some of the most apparent ones. One is SAP, right? We first of all draw the data from SAP in order to show you. Obviously, it's an option; it's not mandatory, but many customers choose it. We show you obviously the health graph. We show you the historical health of every machine and every component. And then we show you also where you performed maintenance in the past or just recently. So what you can do with that is, number one, you can look at the efficiency of your maintenance, because, for example, if you've been red or orange and you're only back to yellow because you haven't tensioned the belt well enough, because lubrication didn't really help and maybe you need to replace that bearing or whatever it is, you can actually see it, right? You can actually see in live what is the quality of the maintenance, and you don't need to guess, because the system just analyzes the data, it shows it to you, and then you can make any decision that you'd like. So showing the past maintenance on top of all that data is very beneficial. And we can also write into SAP, meaning we can create notifications for you. We would never create work orders because that's for the sites to decide what converts into a work order, but we can actually create a notification. We can auto-populate all the fields, right? What's the machine, what we found, what we recommend. You can obviously edit it after it is created, but it really saves some time. So that's number one. With SAP, we really see this integration of maintenance data into what we call telemetry of the machine is very beneficial. And second of all is SCADA. So in SCADA, it connects a bit to the other question, the previous question that you've asked. I would say there are two main modes, right? One is these slow deteriorations. It can be of bearings and looseness and gearboxes and so on. That can really happen over weeks and even months. And there, basically the daily meetings that the maintenance teams have are more than enough. But the other ones are these critical events that need to be handled right now, right? Right now you have some oversized rock that's going towards the chute and might block it. Or maybe the chute is already blocked. Right now we're monitoring, for example, belt damage, right? Right now you have this very large cut in your belt or this severe damage. And in many cases, the operator, and that's not the user there, is not the maintenance team, but rather the operator, would actually want maybe to stop the operation, obviously from safety reasons and other operational reasons. And in their case, we can actually integrate into SCADA and show them the alarm within SCADA. So imagine that we have our own footage from cameras being processed and analyzed using our deep learning and AI and so on, but they eventually translate to the same alarm in SCADA that they are used to, that's convenient for them, familiar for them, and they can just take it from there.
Fantastic.
Yeah.
That's really cool. Who's the primary customer for the product? Like, who's going to use it on a day-to-day basis, and what do you think the main benefits for them are?
Sure. So the main customer are, number one, the maintenance teams. Some sites, by the way, don't even have reliability teams, depending on the geography. So for sure, maintenance teams, when they have their morning sessions and when they ask themselves, what do I need to do in my next shot? What do I need to handle today? They basically, from our experience, open the system. They see basically, okay, these 50 machines are all green, all healthy, but these small portion, these 5-7 machines, these are deteriorating. That's what I need to handle today. So that would be by far our most prominent user. Other users would be Conmon and reliability teams that, again, want to focus their attention. Imagine that instead of going throughout the entire site, that's what they do today, right? Every few weeks, recording vibration manually on literally dozens, if not hundreds of machines. Now they can focus on the cool part, right? On the problem solving, on the diagnosis, where again, we cover all of the healthy part, we focus them on this small portion that's deteriorating. They can look at the data, they can look at the evidence, they can approve it, right? And then they can obviously give the green light for the maintenance teams to handle it, right? To prevent it. So they just don't need to invest their time into just going through hundreds of healthy equipment pieces. And not only that, because it's continuously being monitored, they don't miss anything, right? Because sometimes something might happen over the weekend or over the holiday, Christmas, whatever, and they just got everything completely covered. If something is wrong, they get an SMS message, an email, whatever they configure. So that would be regarding the users. Regarding the benefits, I think that there is here a bit of a deeper vision. And the deeper vision is number one regarding autonomous operations and automatic operations. What we see is that, many people ask, is AI going to replace people? Is AI going to get people fired? From our experience, that's not the case. From our experience, it's the matter of using the teams, number one, more efficiently, but also, as I said, focusing on the more interesting areas, right? Focusing on the hard diagnosis, on the, complex cases, just like doctors, focus on these very unique patients that they need to understand what to do. So the vision is number one, making the site more autonomous, making sure that the machines are aware of themselves, or at least we are aware of what's happening to the machines. And number two is making sure that the entire reliability is just increased, because today, many sites keep on chasing their tails. That gearbox failed. Okay, I'm replacing it with a new one. But after half a year, it fails again. And after half a year, it fails again. So number one, you're looking at costs, but also look at the times of the teams. Look at the safety of the teams that need to be near that equipment periodically. And now imagine a future where you don't need to do that, right? Where you do have this diagnosis saying that's the root cause. You handle it once, and then for many years, you don't see any issues there. And this is the vision. This is the why that drove us to build this product. We actually started with the why, what is the vision? And then we asked ourselves, what data is even required to do that? We saw that the data on site is not enough. So then we went ahead and built that system that gathered this additional data, and then we've built the analytics part and so on. So we really went from the bottom, from the last stage really backwards. But this is really the vision. Autonomous operations where the people are there to really handle the complex parts, the interesting parts, the part that need their attention and their intelligence and their experience. That's the vision.
Yeah, right. So really getting, people handling the edge cases more than the day-to-day stuff that takes, exactly. It just absorbs a lot of time. And humans, we're terrible at that repetitive, or just keeping track of things, aren't we? It's pretty interesting. How have over the years, you must have had a lot of feedback on the product. How have you incorporated that feedback into what you have now, and how's it changed?
Wow, so I don't even know where to start. I'll give several examples. One that we discussed was the evidence. We started from the AI component. We started with, let's perform the diagnosis. And we gave really beautiful diagnosis to the teams. And we've seen that there is today, I think, trust issues in AI. When AI tells you something and you cannot ask why, I think it's not even AI. Every person, right? Even if you speak with a human being that gives you some decision and you cannot ask anything about it, that's really an issue. And even more so in mining and processing, which are conservative industries. So incorporating incorporating what we call the evidence was really crucial. We've put a lot of effort into it, because imagine how many data is being processed, being able to find that portion that a human being can look at and say, okay, I got it. That has been very important. It comes to the fact that when we, for example, show a trend of oversized door, the system actually creates a GIF that shows you the big rocks, as an example. So it's very cool. It really shows you visually what it has found.
Yeah.
And it also means that we expose some of the processing of its spectral processing and so on to really show the user what we have done, how it looks like, and why we think that this gear is gonna fail, or that bearing, or whatever it is. So I think that the evidence was very important towards building trust in the system and really putting it in the workflow of teams, of the teams on site. And I think that would be a major one. I think that another one would be the hardware part. When we started, it was purely software. We knew exactly what we needed, but we saw that many sites were just lacking this information, and putting, the sites through this burden of installing sensors themselves and, performing all the deployment. Also, these gateways, they need to be assembled, mounted. It's a lot of work. And this is why we actually, created this entire department here that deals with hardware. We have local teams that assemble everything, ship it. Literally, they create already existing kits. They just need to be mounted by our personnel. So that was a major shift that we've done a few years ago. Again, from the feedback of customers, from the understanding that the teams on site have enough to do. We don't want to increase their workload. We want to reduce it. So we really build these teams around the globe, all major continents. And now we deploy both hardware and software. So that was another example.
Great examples. Yeah, that's cool.
I mean, you're also a startup founder, so you know the journey. You start with point A, and you don't even know where you're gonna get. So
yeah,
that was the journey, and
100%. Yeah, I mean, we actually have the original PowerPoint slides that Troy put together. We're very careful to keep those sort of locked away. Do not delete, because we're really interested to see from that original thing that he presented to me. He said, what do you think of this? It's only 3 years or 2.5 years ago now, and it's already just
completely
so different, and so many things changed, and so like the direction and all the rest of it. We're really interested to see where it goes over the next few years. So I imagine you would have had that journey over 10 years. It's awesome, but that's what's so fun about a startup, right?
And you've got to be addicted to the adrenaline rush.
Yeah,
because otherwise it kills you. You either are addicted to it and then you can found a startup, or not.
Yeah. Troy rings me every second day, just going, "Oh, why would you do an ordinary job? This is because it's fucking scary."
But you learn a lot. You learn a lot.
Any example you might be able to give, a case study or a couple of examples or case studies of where the product is you can actually demonstrate that made a difference. You gave one about the fan. But I think because I used to work in safety, right, and training, where it's all about prevention, and you put these things in, might be a process, it might be something else, and then all of a sudden, you don't get injuries, and you think that it's working, but it's very hard. It's like, did you save a life today? You don't know. One of the hardest things to do was to prove that you were adding value in safety, and I imagine that with predictive maintenance that might be an issue as well. So how do you quantify the impact you're having?
Okay, it's a different question than you started with.
Sorry, yeah, it is. Answer whichever one you want, because
I can answer both.
Okay.
Then
yeah.
So the first question was about the case studies. I can give two examples that I think are very different, and I think that give pretty good intuition into the system and how we work. Number one example is we have a site in South Africa. It's a precious metal site, basically a very regular processing flow. They have a crushing circuit, then a conveyor, discharge conveyor that feeds the mill. And every few weeks, they used to have downtime in the mill. Basically, just you see in SCADA overload. It says overload, the motor trips, and every time it trips, obviously they start losing hours. they have downtime, they start losing throughput. And it happened every 2, 3, 4 weeks. So it was pretty frequently. And imagine the losses, right? We're discussing each site. We're going to discuss it in the KPIs, the second question that you asked. But every site roughly knows what's the cost of a single hour of throughput. In their case, it was a few, tens of thousands of dollars. And you start making the multiplication, it really accumulates to millions of dollars. And they were handling the mill every time, right? They were replacing this, making that. And one of the deployment there included cameras in the discharge of the crusher. And what we've seen there, right? So we know what is the crusher gap, so we know how large the rocks should be. And we track the oversized ore. We track how large is it. And you see every few weeks, these trends, the oversize increasing. Okay, and obviously this one causes the mill to overload because you have oversized ore going to the mill. Now, if it happens for a minute, nobody cares. But if it happens for a few hours, it accumulates and it just completely trips the mill. So the first time they got the system, the superintendent of maintenance were looking at it. They saw the data, and right, you see, imagine it's visually, you see the GIF of the rocks that are oversized. You see with your eyes, so it's very easy to believe it. And they asked the team, did you maintain the crusher? Is everything okay there? And the team said, yeah, everything is fine, don't worry. And this guy insisted, could you please go and recheck, because I see this increase, it's not going back, and I see it just deteriorating more and more. And after, some persuasion, they just went there. And yeah, the liners, they just forgot to replace them. They were completely worn out. They increased the crusher gap, and that caused the oversized ore. Now, every time it's a different reason. It might be miscalibration of the crusher gap. It might be these liners, whatever it is. And imagine the transformation. It's from guesswork to this data-driven approach. You see the trend, you see the rocks, you know exactly what's wrong. You send your team, they handle it. And we've been deployed there for a year now. They just didn't have it since. So you're speaking about prevention. Imagine millions of dollars, all this downtime that you just had last year, you don't have this year. And that's just purely from, obviously, the cameras, plus the deep learning that measures the rocks, builds the statistics, and so on. So the KPIs, I can also connect to your second question, is, first of all, the new throughput, right? So dozens and dozens of hours of just purely new throughput from the site, purely new recovery. Millions of dollars. Number two is safety, right? You don't need, in their case, they had sometimes crusher blockages. They really would put people inside the crusher to release them. Imagine how unsafe it is. Now you just prevent it from the first place, right? In the first place, you don't even get to these situations. So you cannot quantify how many people would have got injured, right? But you do understand that by being less near or inside, these unsafe machines, that's very beneficial.
Yeah, the risk.
And third, and that's another KPI, is maintenance costs, right? If you don't replace equipment that don't need to be replaced, because that's not the root cause, because the root cause is upstream, fantastic. That's in most cases, a mill motor is so expensive, a mill gearbox is so expensive. It's tens of thousands, even hundreds of thousands of dollars per each replacement, and you just prevent them all together. And the workload of the people on site, right? Their time, their energy, and so on. We had another example of another customer had a very long mill, site shut. And in their mill, they had corrosion forming in the bearing, specifically driven bearing of one of the motor of the mill. And in this case, when it was put back online, the system showed that it already started with orange. We have a system of green, yellow, orange, and red, and very quickly deteriorated to red. And the team there didn't hear anything. They went to the mill, didn't hear anything, and they actually sent a person to record vibration, and they just didn't see anything in the signal. And the reason why we could see it and they couldn't is that, some of these machines are very noisy, right? The mill has so much ore going into it. It can change speed. It changes, so everything changes. And if you just look at regular data, it's impossible in many cases to see something. and our processing, and we can, you know, maybe have a different session about exactly how it works, actually can use the load of the machine, the speed of the machine, can compensate for all of these changes, can remove all this noise, and really see the specific data that shows iteration. And we show them, guys, it's a critical condition. It deteriorates very fast, despite the fact that you cannot see or hear anything. That's the signal. That's what we've seen. And they just used the shot that they had a week after. They removed the motor, put a new one. And when they disassembled it and they looked at the bearing, you see this severe damage that would otherwise, in their case, would break in Christmas time. And, you know, that's, again, at least a day of downtime of a mill, right? So, you know, that's millions of dollars. Just that single incident that was just completely prevented. No Christmas downtime. So really, everything is a completely different other path of, you know, of events. So
great,
that's just examples.
Great examples. Well, it's pretty rare that things don't go wrong over Christmas.
Exactly. Or night, or weekends, or holidays.
Yeah. Definitely, the gremlins like to hold it off for that time. How do you manage ongoing assistance? What kind of input is Razor Labs giving over a period of time to a customer?
Okay, I guess I can say several components. One component is we have obviously the diagnosis and all the systems SaaS we discussed that has the AI, but we have real human beings, and that's very important, that support the site. So most sites actually have weekly sessions with us where they can basically take our experts, people, you know, with 25, 30 years of experience, specifically in mining condition monitoring, so very specific to what they need, and ask any question. What did you see in the data? You told me to change my switching frequency in my VSD. How do I do that? Why do you recommend this one and not that one? My motor has a flexible base. How does it impact your analysis? Why this, not that? Literally any question. And I think it's very important that even though we have AI, we have real people, because eventually it's, you know, a very personal relationship, right? Having a real person you can consult with, you can ask something, whatever it is very important. That's also, by the way, one of the feedbacks that we've got. One of the critical aspects of the relationship that I think it's very important despite all the technology and the AI and so on.
Yeah, cool.
I think I would want to not speak about the product, but speak about the vision, about the why, about the reason why we founded the company and why we even went to that direction. And I think that the message that I want to convey is that the mining industry, but also other similar industries, have huge impact on our lives. And we see that they have huge benefits that can be reaped, you know, from using these technologies. I think everybody today uses ChatGPT, or at least try to use ChatGPT. And imagine having these kinds of smarts into practical, you know, means that help with the operation, help with the maintenance. And as I said, the vision, and I'm putting aside, you know, metrics such as, you know, downtime of millions of dollars and so on, but, you know, the day-to-day life, when I look at the teams on site that are so overworked and have so many challenges, such huge fleet of equipment, they can really leverage this technology to make their lives easier, safer, which is very important, and really make sure that this amazing experience that we see, and we see it really globally in Australia and South Africa and Colombia and others, can really tunnel into what is critical, into these complex cases, into these very interesting use cases. And I think that we're really looking here at the coming revolution, that sites that will embrace it earlier will just benefit it in terms of safety, in terms of their production, in terms of their efficiency, in terms of their workload. And I think that really this is the future. This is what I believe. And I hope that as many sites as as possible join this revolution and really partner with us to bring this future as soon as possible. I mean, really, that's the reason why I come up in the morning. That's wake up in the morning. So
that's great. It's a good message, and yeah, 100% agree. One of the things that mining is critical to everything you said. Like, obviously, we need the steel. We need the steel. We need the coal to make the steel. You need the energy, all the rest of it. But what's terrible, and having worked in the industry, is seeing the waste and the rework and the downtime and all those things, and so to have systems that make it so much more efficient. I used to say to people when they badmouth about, oh well, I don't want mining companies to make money. You go, well, if they're doing well and they're making money, they've got more money for things like remediation, environmental, remediation of environment, more money to pay employees, more money to do things safely. Everything gets better if they make more money. It's when they're wasting tons of money on rework and inefficiencies and all the rest of it. That's when corners start getting cut and things start getting swept under the carpet. And so, yeah, the more efficient and the safer we can make it, the better. Thank you so much. Oh, I really appreciate it.
I wanted to thank you as well. Really, it was really great to get to know you better and to also speak about what we do. Thank you for the opportunity.